Good morning. Today we are going to learn a new form or a new equation. We've been using this equation, slope-intercept form, which is y equals mx plus b. You should know that our y-intercept is where we cross the y-axis, meaning it's either positive up here or negative down here. And our slope is how we create our line, counting rise up and down first, and then run left and right, or using this equation if we have 2 points, x, y. Now we are going to be using this new formula. It's called point-slope form. It's called point-slope form because we need a point, x and y, and a slope, m. If we have those two things, we can plug the point and the slope in to this equation. So one thing to notice, anything that's in black here will always be written every single time. The y minus, the equals, and then our parentheses and x minus. The y1 and x1, these come from our point. There's only one point, so that's why they have the little ones there. Our 1 point gets plugged in for x1 and y1. And then our slope, m, gets plugged in right here for m, slope. So let's take a look at our first problem. It says write an equation in point-slope form. It doesn't say anything about solving, just simply write an equation. So anything that's in black, I'm going to write in black. It says y minus, and then it says y1. So I'm going to label my point here, x, y, and that's my 1 point I have, so I'm just going to put it with ones. So my y1, the number that's going to go right here, is really the number -2. If we have two negatives next to each other, we know those make a positive now. Then it says equals m. So now I'm going to plug in whatever m is, and m is 3. Then there's a parentheses, and it says x minus, that's part of the equation right there, x1. So x1 is really this number right here, 7. And then there's a parentheses again. This is now in point-slope form. This is our answer. We wrote an equation in point-slope form, this form. Let's try another one. I'm going to first label my point, x, y. This is my 1 point that I have. And we know m is our slope. We're going to plug that in for m up here. So if you would like to write this whole equation out, y minus y1 equals our slope, x minus x1, you can, and then we're just going to plug in my x's and y's. So I'm going to plug in a y here, and the x there, and my slope is going to go here. So I'm going to write this y minus y1, which is really this number right here, 1, equals our slope, which is m, which is this whole number, -2/3. You can put the negative on the top or the bottom, but not both. And then in parentheses, x minus, and whatever x1 is, and x1 right here is a -5. Two negatives next to each other we know make a positive. So this is my answer. We wrote an equation in point-slope form. Now we're going to do the exact same thing, but looking at a graph. Write an equation of the line in point-slope form. So my point, x, and y will go in here, and my slope will go in here. So first, looking at this graph, let's pick a point. It does not matter which point you pick. I would suggest picking one of these two that are already labeled. I'm just going to pick this one, 3, 1. If you wanted to pick this point or this point, that's fine. It doesn't matter which point you pick. And then we also need to find our slope, m. Our slope, you need to just count rise over run. How many are you counting up or down, and then left to right? I'm going to just pick these 2 points because they are next to each other. It doesn't matter which 2 points you pick, but I'm going to count up and down first. I'm going to go down -1, -2, -3. So went down 3, -3, and over 1, 2. So there's a 2. If you picked 2 other points, that's fine. You'd still go down 1, 2, 3, and over 1, 2. You get the same answer. So now that we have a point and a slope, we're going to write our equation in point-slope form. So here's x and y. That's my 1 point. So I'm going to plug those in for my x1 and my y1. So our equation says y minus y1, and y1 right here is really 1, equals our slope m, and m is negative 3 over 2, and then in parentheses x minus x1, and x1 right here is 3. If you picked one of the other points for your point, that's fine. I would accept multiple answers for this problem. Your slope should be the same though. So let's look at our next one. I'm going to find our slope first. I'm going to go from this point to this point. So I'm going to count rise 1 and run 1, 2, 3. That was our slope right here, counting rise over run. And then second, we need to pick a point. Any point on this line. I like this one because it's small numbers and it's already labeled 2, negative 1. They got that from the origin going 2 to the right on my x-axis, and then negative 1 is down 1. That's how they found that point. So I'm going to write this in point-slope form. Y minus y1. So I'm going to label my points x, y. This is y, so y is negative 1. 2 negatives there make a positive. And then equals, we have our slope, m, 1 over 3. And then in parentheses, x minus x1, and x1 is 2. That's written in point-slope form. Third one, I would like for you to try this one on your own. Pick a point and a slope, and then plug it in. I'm going to pick this point right here. Oops, I don't know why I put an X there. I'm going to pick this point, but you can pick any point that you'd like. So I'm going to first count my slope. Doesn't matter which 2 points you pick. I'm going to pick these 2. I'm counting up, rising 1, 2, 3, and then running over 1, 2, 3, 4. So my slope is 3 over 4. And then I'm going to write my equation. Here's my point, x, y, that's my 1 point. So it says y minus, from right here, y1, which is really 2, equals m, which is our slope, and my slope is 3 over 4, right here. And then in parentheses, x minus x1, and x1 right here is 6. So there's my equation from that side, from this problem. Next, it says write an equation in point-slope form, then solve for y. So we're moving from this formula up here that we just learned to one that we already know, meaning we just have to solve for y, which is something that we've been practicing. So first, let's just write it in point-slope form. I'm going to label my point x, y. This is my 1 point that I have to plug in. M is already labeled. So I'm going to write y right here minus y1. Our y1 is really a negative 3. We know 2 negatives there make a positive. And then it says equals our slope, m, and m is 2. Then there's a parentheses, and it says x, the letter x, minus x1. And x1 is really, right here, 4. So that's written in point-slope form. Now we need to solve for y. We need to get the letter y all by itself. So first, I see parentheses here. I know I need to distribute. If you want to draw a box to distribute, you can. Some of you can multiply like this without it. That's okay as well. So 2, and then x minus 4. So if we distribute this, 2 times x is 2x. 2 times negative 4, well, 2 times 4 is 8, and it's negative. So I'm going to rewrite this here. We have y plus 3 equals 2x minus 8. If distributing was a little bit challenging, we're going to practice that multiple times today. Remember, this is our teacher out front, and we're distributing or giving candy or giving something to the whole class. You have to multiply, because it's touching, by both numbers. And then last, our goal is to get y by itself, so we need to move this 3. The opposite of adding 3 would be subtracting 3. So those eliminate. 3 minus 3 is 0. We have y equals 2x. And notice I put this 3 under the 8 because we can combine these together. A negative 8 and a negative 3, they're all negatives. It's a total of 8 plus 3, which is 11. I added, same sign, add and keep. So this is solved for y, or slope-intercept form. Easy way to tell which equation is which. This one has a point and a slope, so we call this point-slope form. This one has a slope, m, and a y-intercept, so we call this slope-intercept form. Let's try another one. We're going to write the equation in point-slope form right here, and then solve for y. So here's my point, x, y, my first point, my only point, to plug in. So our equation here says y minus y1, and y1 is really 5, right here, equal to our slope, which is m, negative 2/5, and then in parentheses, x minus x1, and x1 right here is negative 1. We know two negatives there make a positive. So that's written in point-slope form. Now we have to solve for y. So first thing, always we need to get rid of our parentheses. So I'm going to draw a box to distribute. If you can distribute without the box, again, that's okay. Our teacher goes out front and our classroom goes on the top. So when we multiply 2/5 times x, just the same, you're just putting them together, it's still just negative 2/5 x. Negative 2/5 times 1, well, happy and grumpy, they don't get along, so it's still negative. 2/5 one time is still 2/5. Just like 8 times 1 is 8, 10 times 1 is 10, 2/5 times 1 is still 2/5. So here we have y minus 5 equals negative 2/5 x minus 2/5. And then last, we need to get rid of this negative 5 because our goal is to get y by itself. So the opposite of subtracting 5 is adding 5. So we have y equals, we didn't do anything with this negative 2/5 x. We like that as a fraction because if we were to graph it, our slope is already a fraction. Perfect. And then we have negative 2/5 plus 5. I know there's more positives. 5 is a bigger number than 2/5, which is less than 1. If I were you, I would plug this in your calculator. 2/5 is really the same as 0.4. So that's a negative 0.4, really. So if you take in your calculator negative 0.4 plus 5, you should get 4.6. Or 4 3/5 if you did it in your head. So this is solved for y. Doesn't really matter what this number is as long as we have y by itself. Alright, let's go over to the next slide. Now we have an equation that's already written in point-slope form. It says take the equation written in point-slope form. That's this form, y minus y1 equals our slope, x minus x1. They already plugged in the numbers. All we have to do is solve it to get slope-intercept form, or y equals mx plus b. Remember, slope is m, intercept is b. And then graph it. So we want y by itself. First, I'm going to get rid of my parentheses here by drawing a box to distribute. So we have 3, and then x minus 1. Well, 3 times x is 3x. 3 times negative 1 is negative 3. And then I'm just going to rewrite this. Y minus 5 equals, and then whatever's inside your box, 3x minus 3. All we did was distribute or multiply. Get rid of our parentheses. And now we need to get y by itself so it matches this form down here. So the opposite of subtracting 5 is adding 5. So those go away. We have y equals 3x. Negative 3 plus 5, they're different signs. Remember, same sign add and keep, different sign subtract. So 5 minus 3 we're subtracting is 2. And there's more positives, so it's a positive 2. So this is the form y equals 3x plus 2. All I did was just rewrite it there. So now m, our slope, is 3, or as a fraction, 3 over 1, because remember slope is always rise over run. And then b is where we begin on our graph. Oops, begin, if I can spell. Begin at the end here, b is 2. So that's what I'm going to start with. Begin on our y-axis at 2, positive 2, 1, 2. And then our slope tells us how to move. Our slope is rise over run, so up 3 from this point, up 1, 2, 3, and over 1. Up 1, 2, oh, can't go any further, so I'm going to do the opposite. Instead of going up and right, I'm going to go down 3 and 1 to the left. Down 3, 1 to the left. Down 3, 1 to the left. And draw my line through. We have graphed this equation that was once in point-slope form and is now in slope-intercept form. I believe this is the last one. Yep. It's already written for us. All we have to do is solve it and graph it. So first I'm going to distribute or draw my box so I can multiply, get rid of these parentheses. My teacher out front is a negative 2, and my classroom is x minus 2. If you want to put a 1 in front of the x, you may. So negative 2 times 1 is still negative 2 with the x, negative 2x. Here we're multiplying, don't add. Remember, these are touching, we're multiplying. Negative 2 times negative 2 makes a positive. 2 times 2 is 4. So we have y plus 3 equals negative 2x plus 4. We don't have y by itself yet. That's what we're trying to get. We want to get y equals mx plus b because we know how to graph that. So to get rid of this positive 3, we have to subtract 3. So those eliminate, and we get y equals negative 2x plus, because there's more positives, 4 minus 3 is 1. So our equation, if you want to rewrite it here, you can. Otherwise, it's right there. It's in the form y equals mx plus b. So our slope, m, is negative 2, or as a fraction, negative 2 over 1. And b is whatever's added or subtracted to the end. In this case, it's just 1. So we're going to begin at 1. And then our slope is how we move. Remember, it's rise over run. Rising is going up or down. In this case, negative means we're going down 2. So down 1, 2. And positive 1, positive numbers here are to the right. So down 2, 1 to the right. Down 2, 1 to the right. Down 2, 1 to the right. Or instead of going down and right, we can also do the opposite and go up 2 and 1 to the left. Up 2, 1 to the left. Draw your line through. Put your arrows on it. And you're done. Your homework will be very similar to this. You have to write in point-slope form, and then don't forget down here it says solve for y to get y equals mx plus b. So write it and then solve, write it and then solve, just like on your notes here. And on the back side, just like we just did. They're already written. you have to solve for y and graph it.